सिग्नल को फीड कराएंगे तो उसका वेव फॉर्म कैसा है, जो जैसा मान लो हाउस होल्ड जो है, जो एसी जो है, तो एक साइनोसॉइडल वेव फॉर्म, साइन वेव है। तो CRO का जो स्क्रीन होगा तो उसमें हम लोग एक साइन वेव जो है वो देखने के लिए मिलेगा। सो बेसिकली कैथोड रे ऑसिलोस्कोप displays the visual representation of any waveform applied to the input terminal. Okay? So it is basically employed to measure such quantities as peak voltage, तो जैसा मान लो हाउस होल्ड जो है, जो एसी जो है, तो उसका पीक वोल्टेज क्या है, 220 वोल्ट। फ्रीक्वेंसी इसको मेजर करने के लिए जो हाउस होल्ड एसी जो है, तो उसका फ्रीक्वेंसी है कितना, 50 हर्ट्ज। So to measure all these parameters associated with AC form is basically measured by this CRO. Now this oscilloscope consists of cathode ray tube, basically CRT, a vertical amplifier and also a horizontal amplifier, sweep, generator, trigger circuit and associated power supply. Okay. Now you see, this is the basic block diagram cathode ray oscilloscope. So this is basically the cathode. It can deliver the free electrons to this system, and this is the grid. This grid means this basically control the brightness, the output. So these are basically control grid. This is focus adjust. ये क्यों है? क्योंकि देखो, जब यहाँ से इलेक्ट्रॉन जब निकलेगा तो इधर भी जा सकता है, इस साइड में, इस साइड में, ठीक है, और कोई भी हैपोजेट मोशन में ये जा सकता है किधर भी। लेकिन टू गेट नॉइज फ्री आउटपुट वी नीड directional electrons. So to get all those directional electrons, get this output properly, we can use this focus adjust, and all these three parts, this part is basically known as electron gun. Now this is a deflection system, basically a vertical flex and this is a horizontal flex. Here electric fields are applied, in some cases magnetic fields are also applied, and when these electrons passes through these deflection plates, depending on their nature, basically the velocity, the phase, they will deflect from this part to separate region, or in case of, or you may say in a different region of this fluorescent screen. And when all these electrons reach here, then we can see a green colored waveform, and which is basically that waveform which is fed this. Now this is a basic block diagram. Now the CRT is composed of two main parts, electron gun and deflection system. What is electron gun? This electron gun provides a sharply focused electron beam directed toward the fluorescent coated screen from the heated cathode, emits electrons in possibly so many directions. Okay? So here basically this is the electron gun, this part. Okay? So now you see what will happen. The control beam, this provides an axial direction for the electron beam and controls the number and speed of the electrons in the beam. So ये control grid जो है वो basically क्या करेगा, जो इलेक्ट्रॉन गन से जो निकाल रहा है उसको पर्टिकुलर डायरेक्शन देगा और उसका स्पीड जो है वो कंट्रोल होगा थ्रू दिस कंट्रोल ग्रिड. Now the focusing anode. This creates an adjustable electrostatic field between two cylindrical anodes, and then the variable positive voltage on the second anode cylinder, and therefore the focus or sharpness of the bright spot is adjusted properly. Here is like plate. So basically we can use these focusing anodes are this. So these are basically two cylinder, and they can through the electrostatic field between these two cylindrical anode and the voltage and therefore they focus the sharpness of the brightest spot, basically the sharpness of the output. Okay. And the deflection system. This deflection system will basically consist of two pairs of parallel plates, vertical plate and horizontal plates. Okay, and one of the plates in each set is permanently connected to the ground, just to see the 0 volt, and whereas the other plate of each set is connected to the input signals or triggering signals of the CRO. Now the operation. All the basic equipments in case of CFT are briefly discussed. So vertical amplifier, it can amplify the signal at its input prior to the signal being applied to the vertical reflection plates. Horizontal amplifier, it basically amplifies the C signal at its input prior to the signal being applied to the horizontal deflection plates. And switch generator basically develop a voltage at the horizontal deflection plate that increase the linearity with time. Okay. A deflected beam is then further accelerated by very high voltages applied to the tube. Okay. And finally, all those electrons which are ejected from this cathode, they basically reach the phosphorescent material on the inside face of the tube, and as the phosphor glows when they struck by the energetic electrons, so basically we see the visible glow, the green spot on the screen. Okay, and we see the pattern. So this is the basic CRO. This is channel 1, this is channel 2. We can feed any AC, okay, from any generator or from an instrument, and just after doing some fitment, you can get this signal. Okay, so this is basically the signal what I am getting, the fitted signal. Okay, and also we use this channel 2 for time base to measure the parameters, the input AC. Okay, so basically CRO are of 4 kinds: analog CRO, digital CRO, storage CRO, and built-in CRO. Applications of CRO, the very famous applications of CRO are voltage measurements, period and frequency measurement of phase, and we can calculate the phase shift also. This is basically the measurement process. This is the peak to peak voltage, and here there is some graphs, there is some indications, and we just calculate the divisions. Okay, how many divisions are there between these and this, and if each division has some value, just to say this is 0.5, and here there is 13 divisions. So basically the peak to peak voltage will be 6.5 volts. It is very easy to get. Now this is the process. How can we get the peak to peak voltage? Here we have shown these graphs very clearly, okay, and we can measure through this picture the peak to peak voltage. Time is basically here. Basically when we calculate the frequency, so frequency is basically 1 by capital T. The T is basically 1.40 millisecond, because one cycle occupies 2.8 centimeters. Just to see, this is between this and this is the one complete cycle, and this is basically 2.8 centimeters. And if each centimeter corresponds to some fraction, then this T equal to 1.40 millisecond. Okay. Here what we have, this is 5 millisecond per centimeter. So here is 2.8 centimeters. 2.88 into this, and we can get this 1.40 into 10⁻³ seconds. So basically 1.40 millisecond. And when we put this value and we divide it, we will get this. The frequency of this signal is basically 714 Hz. Okay. Now this is the measurement of phase shift. We can calculate the phase shift easily. Just we find out the difference between these two peaks of these two feeded signal, and using this difference we can get the phase shift by using these relations. Okay. Now one important process, we can say the procedure of measurement phase shift is Lissajous pattern. So Lissajous patterns, as you know, basically displayed by applying two AC signals simultaneously to the X plate and the Y plate of an oscilloscope. We have said in the picture. Now the frequency, amplitude and phase difference, different patterns are seen on the screen of the CRO. Just to see, this is basically about Lissajous figure. Okay, you can read it. Okay, and this is the procedure of determining phase shift. So basically, when we get this ellipse, okay, we measure this y1 and this y2 and this x1 and x2, and the phase angle between the two input signal resulting of these ellipse coming out. So this is basically this. So this theta is the phase angle in degrees, and we can get it very easily with CRO. Okay. This is an example. If the distance y1 is 1.8 centimeter, just to see here, this is 1.8 centimeter, and this y2 is 2.3. So basically this y2 is 2.3. So we can get this theta is basically sine inverse this, and this is 51.5 degrees. So the phase difference between the two constituent waves, basically AC waves, is 51.5 degrees. Okay. Thanks to all.